Over the next 35 minutes, I'm hopefully going to challenge some assumptions you might have around data and the value of data through this presentation. I'm going to share what I think is, at the moment, a radically different approach to leveraging value from CMMS, from Maximo, for whatever it is, and deriving what I like to call maintenance intelligence, and finally developing the true meaning of prescriptive and proactive maintenance. Okay? Hopefully I'm going to show you and give you an understanding of what this concept of federated machine learning is at the edge, and how you can integrate that into your existing Maximo workflows. Now, this isn't theoretical. Everything I share with you today, we're doing currently. This presentation is desensitized for a couple of our clients. Okay, if you're switched on enough, you may be able to pick who it is, but I will not confirm who that is. But we are doing this in Melbourne currently with some very large asset owners. So it's not theoretical, it's all practical. But before we dive in, I want to put it to you and hopefully get you to acknowledge something a little bit uncomfortable. We are really, really good at collecting data, aren't we? We've got SCADA systems collecting operational data, some even at 50 hertz, right? That's a lot of data, 50 times a second. We've got sensors, we've got IoT, I hate that term, IoT, but we've got IoT sensors, everything. Everything's connected to the web. Some of these things are producing data streams at 50 hertz. So we're really good at collecting that. My proposition to you is we're really bad at using that. Okay? Now, hopefully that's a little bit uncomfortable. Now, we've all invested heavily in these sensors. Okay? But my proposition is to really derive that value and that return on investment from those data streams, those 50 hertz data streams. We need to invest heavily in the analytics. In my opinion, data has little to no value without analytics. Okay? Now, we all like to tell ourselves that we're data-driven organisations because we've got data. Right? We've got our Maximo instances, we've got our other SQL databases, chock-a-block, full of data. Yet, do some soul searching, and how often do you actually use that to make advanced decisions, rather than looking back historically and saying, oh yeah, now I know why that failed. I've gone through the data and I've found out retrospectively. So we like to call ourselves data-driven organisations, but are we actually using that for our decisions? And how often do we discover those insights 3 months later through dashboards, root cause analysis, right? And sending our maintenance and reliability engineers out to do root cause analysis. How often do we do that retrospectively? Now, I'm going to talk about 4 fundamental problems blocking what I like to call intelligent maintenance. 4 fundamental problems. I'm going to describe how this concept of edge AI or federated machine learning is the silver bullet to those 4 problems. Again, this is all real world stuff. We're doing this in Melbourne. I'm going to give you some practical first steps. If I pique your interest, I'm going to give you practical first steps on how to start doing this. It's actually not that difficult. Okay? Our company, we offer advanced analytics as a service. That's where we make our cheese. Right? Organisations that can't fund and maintain and manage data centre grade assets, we do that. We come in, we do some work, and then we leave and give you the insights. So we're doing this in Melbourne. I've spent my career in the cold face of maintenance and asset management. I started my career as a young graduate at BlueScope Steel, working on the factory floor in the cold mill. Learned a lot of lessons there. Graduated myself up finally into the pulp and paper industry in Melbourne, where I led a team of engineers and a workforce of up to 40 maintenance personnel across 2 paper mills, 19 converting machines. I've seen what works, I've seen what doesn't work. We had SAP, I managed the master data of SAP as part of that role. I've seen what works, I've seen what's failed, I know why. Now, I'm not a vendor, again, like I said. I don't sell software. I'm a practitioner, just sharing our lessons learned, okay? Hopefully we pique an interest for you. My name's Shane Scriven. I'm the founder and managing director of SAS Asset Management. So, hopefully make you a little bit uncomfortable, but I expect you've invested heavily in Maximo, haven't you? Probably spent millions of dollars on Maximo. Seeing Sibelius from COSOL talk exactly about that, right? Around the expense that Maximo brings, okay? I'm sure you've got a whole bunch of licenses, seats. You've spent a lot of time and effort, and probably still do, on implementation, change management, training. What you probably don't see is the increasing storage costs associated with your Maximo instance. But we've spent a lot of money there. We've probably got gigabytes now of work order data sitting there. Do we ever check that? We've probably got terabytes of sensor data, whether it's sitting in Maximo or sitting in Maximo adjacent, but it's still there. But again, uncomfortable truth, it's just sitting there. We're not tapping into it. We're not using it for the most part. We're collecting everything, but we're really learning nothing. It's like having a library with all the books in the world and nobody reads. That's the problem. We're really good at collecting data. We're not really good at advanced analytics. Suddenly your return on investment for your Maximo platforms become the cost of storage, not the analytics and the insights and the value that you're generating from it, okay? Today I'm going to challenge you to think differently about this. Now, I love this slide. Think of your data, your sensor readings. Again, could be at 10 hertz, could be at 20 hertz, could be at 50 hertz, could be 50 times a second we're getting temperature readings from this thing. I want you to think of that as a pixel in a much larger picture of asset health. Now that picture is rapidly changing. At that 50 hertz refresh rate, that pixel's changing. So our picture of asset health is rapidly changing. If we've got a lot of sensors, we've got a high definition image. We've got a lot of pixels, right? It takes somebody to step back and look at this picture in concert with everything else to understand the true story of asset health. Okay? That's advanced analytics. Unfortunately, we treat these things as single data points. Very rarely do we try and learn how they're related, machine learning. Very rarely do we do that. Is it correlation? Is it causation? Understanding those coefficients. Now, multiply that one asset with 10 sensors on it, operating at 50 hertz. Multiply that across your 10,000 assets. Multiply that across your 4 sites in Australia. Perhaps you've got international sites. This gets big really quick. This grows exponentially. I put it to you that data without analysis is just really, really expensive noise. Okay? So this is the question for me that changes everything. This is the mind shift for me. When I learned about federated edge machine learning, this is the question that changed it all for me. Imagine every pump that you operate and manage under your asset management system, it learns from every other pump. Imagine that. It learns from what works, it learns from what fails, it learns from what's normal versus what's abnormal. We end up with this collective wisdom. Just imagine that. We're suddenly taking the human out of that loop and letting the assets talk to one another. Imagine your vendors start to share insights across their clients, right? And you benefit from that. You subscribe into this collective wisdom. That's intelligence maintenance. Cross-site learning, we can start to do that. We can start to truly understand how our crushers work and how they're meant to operate, what normal looks like for our crushers. We can start to understand that as our assets start talking to one another. That vibration spike that we saw a couple of weeks ago that led to a failure, and a really odd vibration. I used to be a vibration analyst, so I'm going to use vibration a lot. I'm sorry. As we see that vibration signature come through, ultimately results in a failure. Now, the second pump, maybe in a different factory, starts to see that same signature, and our assets telling us that, hey, this is a problem. This is what happened last time, right? That's intelligent maintenance, right? That is prescriptive, proactive maintenance. We can finally get there, okay, with federated edge machine learning. And this isn't science fiction, as I said. This is real. We're doing this in Melbourne, okay? It's about to transform how we manage assets on a day-to-day basis. And platforms and tools such as Maximo are the real enablers for this. They hold the work processes and how we actually do maintenance. We're just better informing it through our assets and through our data. So let me show you the problem that we're actually solving. So, sensitised, real-world example. They're not the real buses. That's all AI generated, those images. So you might find little bits that are wrong. Don't judge me. But you've got two buses identical. Bus number 110 has a catastrophic failure in its HVAC system. True story. Set the bus alight. $1 million in lost revenue, profit, and counting. There's a value aspect in there as well that we're not accounting for. Again, post-mortem, retrospective, we jump into our data, don't we? We do the root cause analysis, right? I think you're nodding. We've all been there before, okay? Some GM says, let's find out what went wrong. So off we go. We do our root cause analysis. We find out, yeah, vibration kicked off a couple of weeks earlier, temperature spike, maybe there was a compressor problem. Yeah, it makes sense, right? The holes in the cheese lined up, and we suffered. Now, bus 89 is from a different depot. They both use Maximo, but guess what? They use a different instance, don't they? So the data is there across two siloed systems. True story. Bus 89, about 6 months after this first incident, same vibration spike kicks off again. Same failure mode, 6 months later, same catastrophic failure. True story. We fail to learn from our failures. Edge federated machine learning helps us with that. We keep making the same expensive mistakes, all because our assets are unable to talk to one another. And today they can. It is possible. So I want you to critically look at your organisation and think about just how siloed your organisation is. Different sites, different depots, perhaps you've got different countries of operation, okay? Just think about that how your organisation's structured. Each one, I'm sure, does a really good job of collecting data and condition data, for the most part. And think of those online sensors. Think of SCADA and things like that, okay? Think less about the physical inspection. Think about structured condition data. We do a really good job of it, generally speaking. But each one of those sites, depots, maybe even teams. When I worked at the paper industry, we had different teams. They didn't talk to each other, right? It's not enough time, right? But that data is trapped. They're locked in local systems, not shared across. You might have different business units. Your Melbourne depot, your Melbourne operation really doesn't share anything with Sydney, do they? They're busy. They're busy making stuff, busy doing stuff. You may have like a lessons learned where you all get on every once a month and pat each other on the back, but we're not really sharing, right? Not really sharing the hardcore technical insights is my point. So think of your organisation in that way. So we've built these silos though deliberately, haven't we? And for good reason, like ownership. Someone's got to own that data over there. Someone's got to own that data over there. We've got this thing called data sovereignty, where we need to make sure that the data stays in the appropriate spot and doesn't get leaked, right? We've got these things. We've got compliance. We've got regulatory compliance. We've got all this. The data needs to stay where it is, but ultimately we're paying for this with repeated failures. Perhaps we're cognizant of that. Worse off. Perhaps we don't even know that this is happening over and over again. So, I said before, hate the term IoT, okay? But you think of this cloud analytics approach, okay? And what happens? We've got these sensors. Sensors that are tracking asset data. Typically that'll travel up to a cloud, won't it? It'll go up to a cloud, sit there, some sort of analytics will happen. Okay, whatever that actually is, who knows? Maybe just some regression. And then it'll come back down from the cloud to somewhere, perhaps into some central server. Okay? That can take hundreds of milliseconds if you're lucky, right? That analytics. If you're unlucky, it can take minutes. You add the human into that. Well, now we're at hours, if not days. Okay, for someone to check the dashboard. That's literally it. Check the emails, the push notifications. Latency is a killer in advanced analytics and intelligent maintenance. Okay, the current system set up, very high latency. But that round trip is killing us. Our failures, some of them, high-speed equipment can happen in seconds, if not milliseconds. My point here is the intelligence of that asset needs to sit on the asset for it to be truly effective, rather than in some data centre thousands of kilometres away, if we are to get the true value of intelligent maintenance. Okay? Don't mention network connectivity, because Amazon never goes offline, does it? It's a true story. Did it? There you go. You know, there were some people that couldn't operate their beds because of the AWS went offline. Literally their beds, they had smart beds. They couldn't recline their beds. They had them heated overnight and they were cooking themselves because of AWS went offline. True story. That's the world we live in, like it or not. So privacy, right? We all, oh, geez, your data's sensitive, isn't it? Everyone's data's sensitive, right? Is it really? Well, we don't really bother to look, do we? We just treat everything as sensitive because it's easier, right? Everything's sensitive. Sovereignty is really important. Asset performance data is sensitive, okay? How you operate your assets, that's intellectual property, right? That's your competitive advantage. Maybe the same pump here to the same pump in a competitor, but how you operate that pump sets you apart. So yeah, there is some commercial sensitivities around that. Your configuration, absolutely. How you maintain it, your maintenance strategy, that is sensitive. That's your competitive advantage. I get it. I understand. I'm not advocating for open data, but vendors often won't let us share our data either, and they certainly won't share data across their clients. They've got regulatory compliance. So what do? We hoard our data, right? We put the firewalls around our data, right? It's our data. If it goes out, we need all these controls. I'm going through that with one of our clients at the moment. All these controls around data privacy. It's really front of mind. It's no different in any other industry. Every industry is the same, right? We haven't have the bandwidth nor the time to sit down and say, is that actually a privacy issue or not? We just treat it all as private. And that's probably the most cost-effective way moving forward. And that's okay, is what it is. But ultimately what it stops us doing, we can't pull the data, so we can't pull the knowledge, we can't pull the wisdom of the assets because of that. And federated edge machine learning allows us to do that. It allows us to share insights and knowledge, but not the data itself. That's a really powerful thing. Think about that. So, here is how we solve all those 4 problems.
So edge computing. When I talk about edge computing, right, that's on asset, okay? That is on asset. It's an electric motor, pump, a bus, right? Some sort of compute node, to be tech speak, some sort of industrial computer, on asset, doing stuff, okay? That's edge computing, okay? We're not sending data off to some central node for it to happen elsewhere, okay? That's centralized, edge, on the asset, okay? Now when I say federated machine learning, is we're bringing all these models from all these edge devices and we're bringing them together into an evaluation node. But we're not bringing that data together, we're bringing the insights. If you're tech enough, we're sharing model parameters, not the inputs to those models themselves. And we federate that and we learn a master model, and then we send that master model back out to the assets, an updated model. So this is edge federated machine learning. It's incredibly powerful, incredibly robust, and incredibly efficient. And we are doing this in Melbourne at the moment. These models, it's like having a brain on board, a proper brain, not just an engine control unit or what, right? It's a proper brain, GPUs on board, right? You can get them now, they're the size of a credit card, okay? It's NVIDIA graphics card, and it can punch out some serious analytics on board really quickly. So if you think of a vehicle, right, we've got all this telemetry data, it's GPS data, fault data. We are learning that machine learning model on the bus, on the vehicle, on the tram, on the train. And we are sharing, we are federating that wisdom, those insights from that model up to a aggregating node, a server, which then combines that into a master model and distribute that back out to the edge. Now that's really powerful. If you think of 500 trams, 500 trains, you think of 10,000 pumps. There's a lot of insights that can be generated from having this approach for your assets. Ultimately, what you do is you get fleet-wide or portfolio-wide intelligence, but you maintain site-level security because the data never leaves the boundary, the threshold. Just the insights, just the learning, just the wisdom. And this is possible. This architecture is possible. We're doing it today. So, when I talk about traditional machine learning, if you're not across what that is, and if you think of it in a fleet of buses, we have 20 Hz data streams, all being sent and distributed to a central node. This is traditional. That central node churns through that, right? Suddenly we're at 30, 40, 50 billion lines of data that this poor server needs to chunk through. And if you're lucky, you might get a model that resolves in a week, and then we send that model out and do something about it. I mentioned before about latency. Well, geez, there's a week worth of latency there, isn't there, when something could have gone wrong, okay? That's traditional machine learning. When we talk about edge federated machine learning, that learning happens on board, specific to that bus or whatever, right? And it learns its own context. It learns what is normal. It can then infer what is abnormal, and it can put up its hand and say, I don't feel great today. Something's wrong over here based on all of this, okay? Well, by the way, my friend over here didn't feel all that great 6 months ago, and now I'm feeling the same way, right? That's edge federated machine learning, okay? Ultimately, our assets learn what normal looks like through trending, through anomaly detection. They start to have that brain on board. The other assets out there start to incorporate those learnings in their own. Now appreciate, one may operate faster, one may operate slower, the context is different. But having that global understanding and that distribution of speeds versus performance is what these models would deliver for us. These coefficients of these models are not numbers.
They're probability distributions, a range, right? A range of numbers. And based on certain cofactors and coefficients, it arrives at what is normal. This is all possible. But the key here is no raw data leaves the asset. So sovereignty is maintained, data privacy is maintained. Just the insights, just the wisdom leave. And this learning compounds the more you operate your assets. You get more and more insights. Again, this is not science fiction. This is happening today. So it solves this privacy paradox that I talked about around data sovereignty, compliance, regulatory compliance, and so on. It solves this because the data never leaves. We're simply just talking about the insights, the wisdom. That leaves, that gets shared, and everyone benefits from that. The edge device, if you want, we're moving towards this, can make decisions. We can equip our edge device with things like a knowledge graph, which pulls from systems like Maximo around configuration, work order history, root cause analyses, and form a knowledge graph. Probably not a RAG, probably a knowledge graph, something a bit more structured, right? And it can start to say, well, hey, if my vibration is X and my temperature is Y and my pressures are A, B, C, it's likely to be something like this. So we can actually have our assets infer what the corrective measure might be. How powerful is that? This is possible. These decisions that these assets make are not based solely on their experience, though. They're based on the fleet-wide, the population's experience as well. So again, how many assets? You got 100,000 assets? That is some big collective wisdom. Bet you've got more assets than people in your organisation. So without this, well, in this sort of sense, you don't expose your operational profiles either. So that privacy, again, to labour on the point, is maintained. Super powerful. You ultimately get deep collaboration, programmatically, without the vulnerability of privacy. Okay, we're not shooting data across networks for some little kid in their bedroom to intercept. Okay? Data privacy is maintained. So I'll give you a concrete transport example. So a pantograph. That's not a pantograph, that's a AI representation of a traction motor. Didn't do a great job there. But anywho, pantograph, right? Trams running by here, it's perfect. Didn't plan this, but we've got overhead wires across here, right? Takes the electrical energy down from it into the traction motor, and off it goes. Okay? So these pantographs, they wear out. There's carbon strips, and they rub across that wire, and there is a wear profile. And that wear profile is impacted, well, we believe, it's impacted by weather, duty, speed, also the orientation of the overhead wire itself. This is what we believe. Traditional approach is these wear and performance metrics would be downloaded from the tram periodically. It's got a 10,000 kilometre service or whatever it is, right? It's roughly about 2 weeks for a tram in Melbourne. It's downloaded periodically, so again, there's 10,000 kilometre or 2 week latency there, is then analysed collectively with all the other data points, right? And maybe some insights are produced. Now, if we take the federated approach, well, our tram learns as it runs on the network, learns what the wear profile for a given day on the network in a certain spot, given certain weather conditions. It starts to learn what a normal wear profile is, and therefore can start to tell you or suggest to you, that's probably better language, suggest to you or infer to you that something's not right. Perhaps using our RAG or our knowledge graph from our maintenance work orders, we understand that based off of those readings, our remaining useful life, we can start to predict that. We're in it 2 weeks. We've got a service window in at 1 week, it's highly recommended that we do something about it. This is prescriptive, proactive maintenance. It's the best definition I can find. So if you scale that now, that's one asset. So that's really powerful for one asset. Again, like I said, Melbourne's got about 400 or 500 trams. Scale that across fleet-wide, okay? I don't know how much they've got here in Sydney. I'm from Melbourne, right? But think of your pumps, your electric motors, right? You're in at the tens of thousands, if not more. You start to see the scale gets pretty big pretty quick. That collective intelligence grows exponentially the more you operate your assets. Okay? And again, we're doing this. So back to the latency problem. Edge computing solves this. Machine learning, living on the edge. What's happened? There we go. It's not broke. Machine learning, that data, again, to labour on it, is processed locally. Okay, so it's far more efficient. It's quicker as well. Anomaly detection happens, all before a human knows about it. I love this slide. What I'm trying to do is make every asset a data scientist. Right? Every asset is learning from its own experience, from its own expertise. It's making intelligent recommendations, like I said. Ultimately, it's autonomous all the time. What we've actually done is democratised wisdom and knowledge through our asset base in a programmatic manner. No longer is it sitting in the fitter or the electrician's head for us to try and extract. We're now able to do that programmatically. So how do we do this? Promise, give you some heads up. You can start doing this week. My recommendation in learning what I've learned through this process is pick 1 or 2 failure modes that you know really well. Vibration and temperature are really good ones. Pick a maintenance team that is highly engaged, that are knowledgeable, that you can build and start to structure that knowledge that they have from, because I bet your work order data is incomplete. I've never seen work order data that's complete, doesn't exist. And you start to build that and learn on the go. And then once you get good at that, maybe expand to a couple more failure modes or a couple of different assets. Right? Really important that you demonstrate return on investment and value generation early in these applications. So don't boil the ocean. So implementing this, integration's key. I am a very big advocate for not making more work. I hate work. I had enough work working at BlueScope Steel, right? All these smart endeavours ultimately require more work from maintenance. Condition monitoring techs are a pain in the ass. They just come to me with work, right? They never actually fix the problems. So I'm a real big advocate for integrating into things like Maximo, right? Using APIs to push and pull data from Maximos, using queuing technology. Make sure it's asynchronous though. And what I mean by that is we can send multiple messages at once and then it sits in a queue to be processed. It's not this bottleneck log jam, okay? Asynchronous. Ensure that we're communicating in an asynchronous way. So suddenly when we're starting to generate work orders, we're generating work orders in a fraction of a second from our asset. Really important to structure that well and ensure that we're not saying, do this, right? It's, well, we think something's wrong here. You know, with machine learning, with AI, it's really important to give a confidence attached to that recommendation. Say, 90% probable or 20% probable, both equally important, okay? Really structuring that, integrating that. Ultimately, the goal has to be that your maintenance team have no idea that AI is running in the background. That has to be your objective. No retraining, nothing. They don't need to learn AI. All they see is maybe that little sparkle on the work order that says a bit of an AI insight, okay? That's it. The familiar Maximo dashboards, user interface, none of that changes. We're just integrating our insights into Maximo. Okay? Looking forward, imagine a maintenance planner supervisor comes in the morning and says, opens their list of work orders for the today, and there's a notification saying, well, pump 47 is experiencing high vibration, bit of temperature, and we know with the balance of probabilities that we've probably got 2 weeks until that thing goes pop. Cool. That's the level that our maintenance planners really should be interacting with this AI. And they can then integrate that as part of their workflow. That's what's important. Now look even further, 5 years ahead. Suddenly we've got maintenance schedules that are writing themselves, are flexing up and down. Assets that are performing really well are getting extensions on their maintenance tasks because we don't need to do those maintenance tasks. There's no evidence to suggest that anything is wrong or that anything will be wrong based on the context and the demand profile. This is all very possible. Whereas those bad actors or those assets that are under stress get more attention. So what we actually end up doing there is normalising and balancing load across the assets, all through edge federated machine learning. So I started out basically calling your Maximo data worthless. That was pretty provocative, wasn't it? I'm sorry if I upset you. But I hope you've at least got now an understanding of where I'm coming from. The point still stands. Unused data, to me, has little to no value unless it's analysed deeply and understood really well and also acted upon. Edge federated machine learning transforms that data into distributed intelligence. That's what it does. It democratises wisdom and knowledge. It is possible. Your assets become self-aware. They become collaborative. Always continuously improving. You get the benefits of big data without the price tag, without the security concerns, the privacy risk, the dependence on AWS. We can move from reactive and preventative maintenance into truly predictive and prescriptive maintenance. This is the vehicle to let us do this. Your competitive advantage stays with you, but it also compounds as you learn more from your assets. It compounds exponentially as you operate them more. The question really isn't about whether this is coming. It's here. It's happening in Melbourne. It's where are you going to be? You're going to be a leader or a lagger? Thank you very much. I've enjoyed this. Thanks for indulging me. If you've got any questions, please let me know. Thank you. Hi.
Typically you hear about you need good data
Okay.
for this kind of, for any AI to work. Is that very similar in this case as well?
No, I very rarely come across good data. Okay. Data quality is a thing to talk about, sure, but any good data science accounts for that. Uncertainty analysis. And I like to say, before we had structured data, way back when, we still did asset management, didn't we? We still made decisions. A good asset manager can make a decision in the face of uncertainty. Okay? Absolutely. So you don't necessarily need excellent quality data. Sure, it helps, absolutely. Systems like Maximo, where they're looking at data control for the most part, quality control on the data coming in, right? They help, certainly, but it's not a showstopper at all. This is why when I say it's really important when you produce an AI insight that you also follow up with some uncertainty and say, look, balance of probabilities, 20%, this is my best guess. Because that's what it is. It's an educated guess at the end of the day. So it's not a showstopper, no.
Yeah, so I was thinking of like, for instance, if you've got, say, a bunch of assets that are classified the same, but they're actually, when they do the same thing, they're way different in design or make model,
Sure.
revision, all that sort of stuff.
Yep.
Like if it's a centrifugal pump versus like an axial
Absolutely. And you will see it in the insights. Yeah.
It'll just sort of over time get better, I guess.
Absolutely. And it'll present things in a distribution and say, look, there's a cohort of stuff over here, and there's a cohort of stuff over here. Asset manager, maybe tell me what's going on here, because normal operation is vastly different, for sure. Absolutely. Any other questions?
How different it is like from the traditional IBM predict, monitor,
Yeah.
head,
Yeah.
compared to AGI? Like, what differences you see?
Extreme speed. We are talking about from data collection, sensor collection, to compute, to insight, to milliseconds. And if you then enable your edge device to provide with probably use a small language model rather than a large language model, smaller, perhaps fine-tuned, equip that with a knowledge graph, you're getting insights immediately. And if then you enable that with some form of API or hazard, to use the term agentic control, you can act before a human even knows about it, right? And that's really, really powerful. If you get to that point, there's a maturity thing here, absolutely, right? But this is the art of the possible, okay? And this is where we're moving towards. Really good question. Yeah. Any other question?
Talk a lot about fleet assets. Right?
Yeah.
It's fair to say, obviously, this is not just limited to fleet.
Nope.
Is there particular asset types that you see lend themselves better, or is it
Yeah.
same, a little different?
Fleet assets are really good because they are collecting data already. That ECU, or the multiple ECUs and fleet vehicles, are collecting data. And I liken that to the garden hose that's got no end on it. For the most part, those fleet assets, that data is just pouring out the end and no one's collecting it. It's only when it forms a fault, we plug in our OBD detector from a mechanic and we say, oh yeah, the engine light's on because of X, Y, Z, right? Fleet assets are probably the easiest assets to start with.
Because they're already collecting it.
The data's there and it's rich, right? It's some of these OBD systems are sitting at 100 hertz. Yeah, for sure, on the CAN bus. Yeah, good question. Thank you very much, it's been a pleasure. If you want to talk more, come say hello. Appreciate it.